Hey, welcome everybody. Thanks for coming to our talk. My name is Hart Rossman, and I'm with the AWS Professional Services team. I lead our global security risk and compliance practice. Our practice works with our largest enterprise customers to help them make good decisions about security control selection and compliance as they move their workloads into the AWS environment. You'll also be hearing today from some of my esteemed colleagues, Bill Shin, who is a principal security solutions architect with AWS, and Brent Funk, who's with us from Boeing, who's going to give a customer case study today. One of the things that we've had the opportunity to do in professional services is work with a lot of customers over the last several years. And as part of that activity, we've been able to observe some patterns in the way customers adopt the AWS environment. And so this year, we've been talking in a number of other sessions about the cloud adoption framework. And one of the elements of that is the security perspective. And that talks to how customers have thought about and how we can help you organize your cloud migration around some important security tenets like security strategy and building security operations playbooks and a number of other core things. And that's important because the security pace of innovation in AWS is quite honestly pretty astronomical, right? Today, I think they announced that we've released about 454 major services and features to date, right, just in 2014 here at AWS. And of those, 167 were security or compliance features that everybody benefits from when you move into the AWS environment. And so one of the things that you observe is that individual Lego blocks or building blocks for security are helpful, but developing patterns and solutions that are repeatable, right, really gives you a leg up in terms of having really tight security operations. So what we're going to be talking about today are a number of these enterprise security patterns that high-performing organizations in the AWS environment are using to be successful.
Thanks, Hart. I'm Bill Shin. I'm a principal security solution architect. As Hart mentioned, I spend a lot of time talking to customers as they move their workloads to Amazon. I think about all the things like privacy, compliance, risk management, technical security, and a lot of governance issues too, as well as how you run your security program and how that program might need to adapt to the way you would implement controls on AWS that might be a little different than on premises in some cases. So what we'll do is talk about some patterns. Last year we talked about capabilities, and that was to align sort of your use of Amazon Web Services to maybe an enterprise architecture framework that you might have in your existing enterprise environment. That included things like anticipating, preventing or deterring, detecting, responding, and recovering. And those capabilities, we aligned those to the services and all the features in the services and how you'd use the features to affect or bring about those capabilities for enterprise. This year we decided to take a pattern approach, I guess. These are maybe behaviors, maybe they're technology decisions or implementations. They're not necessarily in any particular order. All of these should be fairly iterative as you move your workload to us anyway. But these are the things we see in our most mature customers. And these are the things we see that are highly effective, and they've been able to get more value out of their move to the cloud because of the behaviors that they've, or the patterns they've implemented. So first is a security leadership program. This may seem simple or like, thank you, obvious solution architect, but really it's very important to have a place for security to land. And by that I mean whenever there's a decision that needs to be made about configuring something this way or putting data in this service or not in this service, and someone has to own that decision. And there should be a process by which these decisions are made that's I guess internalized throughout the team. So the four indicators we see of highly successful security programs, they've arrived at a control framework. It doesn't, you can be wrong, just don't be confused about what it is. So the important part is to pick one, and you may have enterprise standards that define control objectives, and then you can map those control objectives to the way you implement them. But it's important to have a control framework socialized. That can be NIST 853 at a particular FISMA level, or there can be ISO 27001, PCI. We've seen all of them. But the ones who have moved the fastest to the cloud are the ones where they've decided as an organization that this is going to be their framework. Otherwise, there's just this continuous and endless debate about how we measure success and how we measure whether we're secure or not, right, when you move your workload to us. So if you know definitively that you've got evidence to map to a control framework, you can demonstrate that you have performed due diligence and that you're feeling safe. Roles and responsibilities are responsible, accountable, communicated, informed, or consulted informed. We should know who owns the task, right? So if there's a control, who owns it? Is it Amazon? Is it somebody in the organization? Is it development? Is it security? Who's implementing the control and who's responsible for it and for its success? A prioritization criteria. So there will always be things to talk about in security. It's a changing threat landscape. We're launching new services all the time. You're taking on new technologies, moving different kinds of data to the cloud, and there will always be a discussion to be had about some new security thing. It doesn't end, and it shouldn't. But when the next big thing comes up, whether it's a vulnerability or an opportunity to harden something or make something more secure, where does that go in the work effort, right? There's this, you stack rank them and say, okay, here's the line that we're going to focus on right now. And that way it keeps the team focused. It also helps us help you if we know what the priorities are. Enterprise security strategy is something we also see. So Hart's going to take that one, I think. Oh, sorry. Actually, the shared responsibility model too. You've all seen this. I'm going to plug it again. It goes really well with the RACI conversation because having a really clear sense of roles and responsibility for each control and then understanding where Amazon owns controls and where you own controls is pretty critical. One thing that we added to this a little bit in this particular talk is the business, right? It could be that Amazon has controls, the IT organization or the DevOps team has controls, and they own them, and then the business has some controls too to do risk assessments, to make risk decisions. And the partner ecosystem. That's something that we've added this year. We increasingly see on pro-server engagements as well as with customers that people are using a lot of partners. It could be SIs, it could be ISVs, it could be SaaS solutions for security or for other parts of the architecture. It's very important to include these components in the RACI when it comes to owning controls.
Yeah, cool. So last year we talked a lot about the importance of enterprise security strategy. And what we've done is try a number of different ways over the years to help our enterprise customers make those good risk-based decisions and make good security control decisions. And one of the things we found is that many of these enterprises, right, folks that we have in the room here today, already have an enterprise security strategy, right? And so the question is, how can you get the minimal effort invested in adjusting that to support your migration to the cloud, right? Without having to do a lot of rework and without having to create a 200-page tome that nobody's going to read anyway, right? And so we've kind of settled on this model that seems to be quite effective and we've used with a number of customers globally to drive that uplift of your strategy to the cloud. And it's really pretty basic. We start with goal-level security capabilities that anticipate through recover that Bill talked about earlier. And then we look at what are the transformational principles that we want to hold the organization accountable to as you migrate into the cloud. So how do you, for instance, train the organization in security and risk and compliance to treat infrastructure as code and to focus on that as part of the discipline of the way they do business? Or how do you get them to stay current and run secure, right? One of the things we talk to customers about often is with this blistering pace of innovation, particularly around security features and services, when we're releasing multiples a week, how do you get that through your technology risk assessment process fast enough to get your time to value very short, right? New great security feature comes out, benefits the entire organization. How do we get that onboarded and approved for enterprise use, right? Instead of most organizations which think about that quarterly or annually, you're kind of doing that daily or weekly now in the AWS environment. Or even thinking about forensic readiness, right? How do we uplift our forensic and incident response strategies? And then the last part of that is using the cultural principles that you want to see diffused among your organization to build an action plan, to build a roadmap. And so that's where you can look at what are the specific actions and what are the metrics so that we can be confident that we're doing a good job of adopting this cultural principle, right, throughout the organization. And what we found is that what this generates is a 10 to 12 page cloud security strategy, right, that dovetails nicely with your existing enterprise security strategy and roadmap and allows you to just think critically about the most important elements that are going to be driving change and positive security operations in the cloud. Once you've got some thinking around your strategy, and as Bill pointed out earlier, none of this is start to finish. In other words, you're doing a lot of these patterns concurrently, right, in parallel, and you're iterating quickly to start with a minimal viable approach and then getting more mature over time. you've got to start with the basics. And so at some level, I feel a little pedestrian sort of reminding folks of this, but at the same time, it bears repeating maybe for some new folks on the platform. The first thing is get comfortable with the documentation available to you today. Right? Security folks often gravitate immediately towards the security and compliance centers on the website, which has a lot of fantastic information. But the implementation details are in the developers' docs. Right? So once you read the security best practices or the risk and compliance white paper, how you're going to think about implementing that is going to be in each of the services' individual documentation in the developer's guide. Right? When possible, and I know you heard this in the keynotes, always use a multi-availability zone deployment, right? And if it makes sense, go for a multi-region strategy as well. Tune the embedded security features, right? Take full advantage of everything that's baked in. So whether it's security groups and NACLs or the ability to turn on CloudTrail, right, on all your accounts, just do that, right? Don't save it for later. Do it day one, every deployment, every account that gets set up, right? And tune it over time. Don't wait till you have the perfect security group rule set before you elect to turn on a robust set of controls, right? Encrypt your data, right? I know Steve Schmidt talked about that. We have announced a number of cool services around that this week, including the key management service. We're trying to make it as easy as possible to do the right thing, and this is one of those things that's the right thing to do, regardless of the environment you're in, whether it's on-premise or in the cloud, right? Instrument your environment. Not only do we have CloudTrail and CloudWatch, but we also have logging and instrumentation features in virtually every service we offer today. Right? So if you're not familiar with what those logging and audit and notification features are, it's in the service documentation. Take full advantage of it. Instead of having just 2 log sources, you've got over 40. Right? Definitely start consuming those and making use of them. Leverage our constantly improving security baseline. That's not only taking advantage of our security assurance and compliance team, which is getting additional certifications for the underlying platform in which you operate, and we announced this week ISO 9001 certification. But also, right, these constant releases of features. I go back to this idea that instead of thinking about your technology risk assessment and readiness reviews that you might do quarterly or annually, you've got to work to become more agile, right? And think about how do we do this weekly, right? Or maybe even monthly. But quarterly or annually won't cut it, right? You'll constantly come up with brilliant workload ideas that the security team will say, well, there's no feature available for that. And you'll helpfully go to the website and say, well, AWS released that 4 months ago. Right? When do we get to consume that feature? So you got to become more agile around that. And finally, familiarize yourself with the marketplace and our partner environment. Marketplace alone has over 200 security ISVs, right, which have a fantastic set of solutions to augment what you might be doing on our platform natively. And we've got an increasing number of partners with some incredibly savvy security skills who are interested in working with you on a solution set that might fit your specific needs. All right? So with the basics kind of accounted for, we want to think about security reference architectures. And I think the key to this is really twofold. The first is it's a plural. Right? I engage with lots of customers who want me to somehow magically draw them the security reference architecture. With the diversity of possibilities, right, through the composition of the 40+ services we have on the platform today, and the enterprise software you want to deploy in our environment, there is no one single omnibus security reference architecture that will meet all your needs. So you've got to start thinking in layers, defense in depth, so you can build composable security reference architectures, right, that will add value depending on the deployment scenario. And this is another one of those scenarios where you don't have to wait to get it right and get it perfect before you start moving forward, right? As Bill pointed out earlier, it's important to make a decision. You want to be clear about it. You don't want to be confused, right, about what the right way to go. And then you want to iterate quickly. Right? So one example of this is maybe thinking about it again in a layered approach. So we have customers who will ask us about anti-DDoS solutions. That talk is actually going on right now in parallel. So I thought it'd be a good idea to at least give you one example here because you're not able to sit in the full presentation. And this is this idea of developing an ambiguous attack surface. And what we mean by that is having a layered set of technology and a layered set of orchestrated operations that make it very difficult to be overwhelmed by a determined attacker, right, in a distributed scenario. And so in this particular case, what we're seeing is this idea that you can use CloudFront, Route 53, S3, Amazon S3, a multi-AZ auto-scaling deployment, right, to begin to create layers of buffer for DDoS traffic. And then you can also architect your application in such a way that would provide further resilience. And in this particular scenario, we're suggesting that you might want to consider some shuffle sharding, right, as part of your data deployment strategy to further reduce the possibility that any particular element in your data set can be overwhelmed by a high volume of requests, right, or puts. So here's this idea that you can take a ambiguous attack surface strategy, right, align it with an architecture that will work in many scenarios, and then layer on additional architectures around that and within it, right, to get to a composable set of solutions that are going to meet your needs and meet your line of business needs, rather than trying to set out and create this omnibus enterprise security reference architecture that's going to somehow incorporate everything that you want to do and that we have to offer.
Thanks. One of the things that I'm really passionate about with customers is, and this one should be one of the patterns that's a fairly early pattern in the adoption, at least start thinking about how to approach this. Workforce lifecycle management is incredibly important as you move to use cloud services, and AWS is no exception. One of the things, especially at enterprises, they've spent a significant amount of time and effort and investment of capital to build identity management systems. That's everything from directories and LDAPs to single sign-on to provisioning and attestation, entitlement reporting, and the whole identity governance lifecycle. And these are big, complicated systems. Integrate with PeopleSoft, Workday, SAP on one side, all the way down into Unix systems and CICS or mainframes and Windows groups and everything imaginable. They're kind of the middle of the IT stack. So use them, right? I mean, don't just get identity access management credentials on AWS and call it good. Those aren't connected to the employee lifecycle, or the workforce lifecycle. So when employees change roles, come and go from the company, contractors and SIs in particular that have access to your Amazon resources to help out, that should be tied to a source of truth for authentication and authorization in the enterprise. And it's awesome the things you can do now. With the launch of directory services and connected directory, you can have two different kind of directions, at least out of kind of very simple ways to get to your existing active directories or LDAPs. There's SAML integration, SAML 2.0 integration that we launched some time ago, where if you have an IDP, paying or ADFS or something in your enterprise, you can define groups in Active Directory, and then based on you go to your internal SAML or IDP endpoint, it looks up what groups you're in, and those correspond to roles on the Amazon side. And if you are in multiple roles, you can select the role, and you can use that across accounts too. The other direction, kind of per account on the AWS side, is this notion of a connected directory. It allows you to connect, kind of your cloud and your AWS account to an existing AD. That can be in AWS too, or it can be over Direct Connect or IPsec VPN back into your company. And then in that side, in the service, the directory service, you align groups or users, but preferably groups, to IAM roles. And then that way, people can sign right into the console with their Active Directory credentials, and then they'll assume the roles that you've mapped their group membership to. Very powerful tool, easy to get going in terms of making sure that they don't have a one-off credential. We've seen it in all cases too, and this is an iterative thing. If that takes a significant amount of work for you, having a process at least, right? Have a manual process if you have to, or change an attribute in AD or change an attribute in the identity governance system that says this person has an IAM account, or this person is a developer with IAM keys that can be used outside of the existing single sign-on infrastructure or the source of truth for authentication. Critically important, incredibly important for compliance to be able to demonstrate control effectiveness for HIPAA, PCI, any of your internal standards. So absolutely pretty important. I also encourage people to sort of tell stories about what they want the developer experience to be. So user experience, I think, is critical for business users as well as for IT staff. What do you want that experience to be? I mean, tell a story. A developer wakes up in the morning, goes to the coffee shop, and VPNs directly into, or do the SSH right into a box. I mean, is that the experience that you're comfortable with? If so, great. But define those ahead of time and tell those stories, right? And the other, more likely, it's you'd like them to use their existing enterprise provisioned laptop to two-factor access into your existing IPsec VPNs, or SSL VPNs at your existing company, and then go through that to a Bastion host running inside of AWS in a DMZ, and from there use two-factor authentication to get to another host, right? Or you don't want them to have any access, and you have them cut a change ticket. At the time the change ticket goes into effect, it opens up a security group, launches a Bastion host with a script, they log in, and the whole thing shuts down in an hour. But define this story, right? And you may have more than one, to Hart's point about reference architectures. So it helps us architect with you, to that story. So the developer experience is key. You want to kind of think about it in terms of productivity and agility too. And there can be a trade-off, right? So that's important. So think about those up front, and then the full circle, right? This is kind of an example visually of cross-account roles. It's often a feature that we find people maybe aren't using as much. Big enterprises tend to have anywhere from more than one, usually almost always more than one, the 10 accounts all the way up to hundreds of AWS accounts. And those may be started by IT for different projects or different business units. They could be through acquisition or mergers. They could be through developers who went and got an AWS account, and then they're trying to tie that back into some enterprise governance. So cross-account roles are extremely powerful. First of all, it's all temporary access when you assume that role in the child account. So you have that master account or central account on the bottom that has the either federated integration with your identity store or the source of users and IAM groups and users that have the capability and the trust with those child accounts to assume roles in those child accounts. But then with that temporary access that you get from the assumed role, you can take action against the assets and resources in those child accounts. So you assume a role, you get a temporary access ID, secret, and token, and then you run your commands against the APIs in the sub-accounts, which gives you, you don't have to provision into those child accounts then individual users. You can just assume roles. So very powerful feature for large enterprise governance. Before I get Brent up on stage, the other pattern that we see is kind of an early move for successful companies that are getting the most out of us and the value the quickest, is that they've set up ubiquitous logging. Like they have just these massive centralized logging infrastructures that could be Splunk, it could be Sumo Logic, it could be what Brent will speak to. And it's a powerful thing because as you start moving to the cloud, you want that visibility, right? And the benefit is that's expensive on-prem to do that, on premises. To set up big ubiquitous logging systems. On the cloud, it's very cheap. You have Glacier, you have S3, you have ways to scale out to support that architecture. And I've talked to, my hoarse voice, I've talked to hundreds of people this week. And just to plug a quick feature that was announced right before reInvent that may have gotten missed. We integrated CloudTrail logs, a very powerful feature for fine-grained auditing of IAM, or fine-grained auditing of API calls. We integrated that with CloudWatch logs, which there's not there is a console for that, but the key thing is that you can create, you don't have to do anything now to get the CloudTrail logs into CloudWatch. They can go directly in there as a target, and you can then write rules and alerts and alarms based on thresholds of API calls. So without any sort of SIM solution or logging solution, you can get some very basic, value out of CloudWatch logs for things like mutating identity and access management calls, security group changes, anything that's it's changing subnets and routes. So it's a really great feature for getting ubiquitous logging of at least the AWS part for very almost nothing. So get Brent up here and talk about how Boeing does this.
All right, thank you, Bill. So Boeing is basically, we have a digital airline project that we're rolling out as part of the Amazon environment, and it's really around providing the software as a service capabilities and integrating all the fleet of solutions that Boeing has and working them together using a service-oriented architecture. But more importantly, from a Boeing perspective, is information security and security first as part of the design. So everything that we're doing as part of the platform is really the enabler for driving more cloud adoption within Boeing as part of the digital aviation and be able to integrate those solutions better across. So I'm going to go a little bit into around how we're approaching, kind of goes back to the total visibility stuff that Hart had mentioned, but also around the layered approach for security and how we're approaching the application tier-based security within our infrastructure. So in general, from our overall, we need some strategy for having an architecture to be able to prescribe and and also to communicate with information security to discuss how are we approaching the general defense mechanisms that's coming into the infrastructure. And so from an abstracted point of view, the way all of our application tiers work, and what's interesting about our environment is it is a multi-tenant capability. If you think from an enterprise perspective, we have multiple different organizations and different projects all being deployed on the same infrastructure. And just as in general and as important as perimeter-based security is from the World Wide Web, it's as important internally to make sure that the security across the different tiers are also secured. And so when we go out and talk to information security, we approach all of our infrastructure kind of around 3 basic premises for our security: the general ingress capabilities and how we're tracking and managing and securing the incoming communication, and then of course how that entry point or that door can actually provide the communication to the underlying infrastructure. And what's important, and because this is a very generic overview around how our application tiers are structured within Amazon, but most importantly is you have to have that security group around a custom set of infrastructure necessary for that tier. And so we provide a security group around that to allow complete communication and capabilities across all those instances. And from an information security perspective, that makes sense because now they understand that all of the communication is isolated within that set of infrastructure. So I know this is all about ubiquitous logging, but it's important to have a general reference architecture and how we're approaching our general layout. And this also aligns a lot with how we're also securing our logging tier as well. So for a lot of our logging right now, and I think it's really important to note, in most legacy applications, there's always the question around what kind of log data do you want to display in production. Sometimes the log rotation becomes a major problem. Disk space, it's very expensive, that was what was just noted. But Amazon gets away with that completely. You don't have any of those kind of limitations. We can scale as much as we want. We can have as much data out there. And so our principle is really log everything. And the most important thing around our logging architecture is making sure that it is decoupled from the runtime of the system. The last thing we want to do is to be logging lots of information and then having that logging capability impact the runtime of the system. So the benefits and what we're using as ELK with Elasticsearch, Kibana, and Logstash, and the critical and aspects of that's really important about that is that with Logstash, we put that agent on every individual server. And that basically takes all of the logs, aggregates them, throws them into SQS, and then we have Logstash indexers that can scale as necessary to be loading up our index for all of our visualization needs. And I'll show you a little bit around Kibana in a second. But the most important thing here, and it's really critical to note, and why Logstash was such a critical piece, is it's not tied to our general application framework. It's very neutral from what it gets used. We can use it for all of our OSEC logs. We have servers that actually use an OSEC agent that pulls down all of our cloud trail and cloud watch data and stores it all in a centralized repository. Because the most important thing to understand is that as part of a security practice, and what we're doing from with a Boeing perspective within the platform, is being able to find all that data, knowing how to correlate it together, knowing that, hey, we're having stability issues with the server. Well, it may not have anything to do with the server. It could have something to do with a threat that's being exposed that we didn't know from somewhere else. So being able to tie all that together gets us to be able to have a better strategy for doing threat analysis and mitigations. So the general logical architecture around how ELK is kind of set up in our environment is we use a lot of the private load balancers provided by AWS for managing the data ingest capabilities, as well as our capabilities to be able to support the Kibana dashboard. And so, as I mentioned, we have Logstash agents on all the instances, and they, of course, make use of the same Elastic load balancers provided for Elasticsearch to load the data, and we use that also for Kibana. And so this provides us a very scalable infrastructure to support logging. And because of all of the auto-scaling capabilities that Amazon provides, with regards to CloudWatch, for instance, we can use SQS QDepth as a mechanism for scaling up more and more nodes to process and ingest the data. So kind of an example to put up a value slide to understand kind of what we're gaining here. So we have these dashboards within Kibana are extremely dynamic and they're very easy. It only takes about 5 minutes to kind of go through. And it basically interacts directly with all of your data. And you can go in there and you can highlight and capture from a time. So if you wanted to drill down, in this scenario, I have 2 different reports on the same time frame that's showing unauthorized SSH attempts, and then of course when you go down, you can see all the log data down below because it's all in the same location. So you can start finding that you have certain IP addresses or different geographic regions that are causing issues that are trying to interact with your infrastructure directly, but then you can also try to see if there's a correlation with how they're interacting with all of your web application tiers. And so that's the value of having all the capabilities there. And in addition, one and most important thing from an information security perspective is the biggest thing that they want to know is that we have all the data to prove that we're making sure that we're mitigating any threats that are exposed on the system. So having this data and being able to do it real time is really important, because one thing that we're continuing to work and improve upon is be able to take this exact same information, automatically and dynamically specify networking rules, scaling group changes or whatever, and then as soon as those changes are placed within the infrastructure, in real time we can go and make sure that those are now mitigated. So with that, I'll bring it back to you guys.
Cool, thank you, Brent.
Thanks, Brent. It's pretty awesome, and it's all open source stuff too, so great. So one of the key patterns too is what we call mechanized asset management. Big enterprises with thousands and thousands and thousands of hosts. I've always thought that that's, the asset management part is the Achilles heel to security. It's been the hardest problem for security practitioners as long as I've been in security, and getting an accurate set of, like, what is the universe of things I have to protect is an ongoing challenge, because you can't secure what you don't manage, right? So the beauty of AWS, right, and just the software deployed security and the way you're deploying things into AWS is that you can use the APIs to reconcile your asset systems, right? You get all this metadata in EC2, anything that you can describe. All of our APIs, have a set of describe method calls that give you rich information about the assets, and that's something that's quite easy to use, especially with cross-account roles. So if you have a central security organization that needs to be able to say, scan and do vulnerability scans, or know if agents are deployed on all the hosts for, unified security kind of agents and things like that, you can use those cross-account roles to query all of the EC2 instances in all the child accounts, get back the metadata, things like internal private IP address, tag values, so that you can prioritize by what the tags are. A lot of people are using data classification tags on EC2 instances, so that you say, data classification low, medium, high, or green, yellow, red, or whatever, and then based on that you make other security decisions to prioritize scans, to do hardening assessments, things like that. So it's a great foundation to start early with, is getting that asset metadata information integrated into some sort of asset management system. The other thing too, and we have the config service now, which I think everybody should be very excited about from a security perspective, gives you rich information about the state changes across all the objects in AWS. That's going to be a very powerful thing for security folks. So as things change, you're getting a view of that. It does tend to cause a little rethinking about the CMDB schema that you may have. So big companies, they have these configuration management database systems that tend to treat the servers, as pets, right? So they have, that's the CI is the server sometimes, and it's got this kind of fixed schema for all the attributes of a server. In an auto-scaling environment, right, that kind of is a little different. They have some issues being resilient to the sort of the up-down nature of auto-scaling environments. So you can do that. You can live update the API of a CMDB and get that data going in there and out of there, as long as it's graceful, right? But the code that does the infrastructure deployment becomes kind of the new CMDB artifact. So the CloudFormation template, or a script that's written to deploy some code, or deploy some resources and assets. The benefit of doing this programmatically, right, is that all the soft data that you have to enter into a CMDB, it's not being done programmatically, so it relies on human accuracy and information, and that hard tie when you do it programmatically is always going to be right. As long as your software is working, right, but it's going to be much more often right and complete than the humans entering things into CMDBs. So really powerful.
Cool. Yeah, well, one of the nice things to add to that is that with the addition of AWS Service Catalog, you have the ability to provide some rationalization and bounding for the kind of environments that your customers are going to be pulling, right, and deploying into the environment. And that adds sort of another layer to the AWS config service in terms of having that right rationalization. when we came and talked about this last year, we talked about the security management layer. And at the time, customers were really taking two approaches. One is they were trying to backhaul a lot of their security relevant data on premise. So what they were doing is they were pushing their workloads into the cloud and then trying to backhaul lots of stuff on premise. And there was a lot of frustration for customers there. There were issues around key management. There were issues around latency. There were issues around visibility, right? It was a little bit like trying to put a square peg in a round hole. The other thing they were doing was thinking about how do they forward integrate their security management layer into the AWS environment. And often what they would start thinking about was reducing the available attack surface by leveraging bastion hosts, with the idea that in a fully automated lights out environment, first of all, the need to turn a bastion host up triggered an alarm and a response, right? Something was unusual that was going on. When the bastion host was down, you had near zero attack surface in the environment. And when the bastion host was up, it was for a specific reason. Hopefully there was a CM or an incident or event that was being logged. And then whatever that privileged user was doing via the bastion host was being managed and monitored appropriately. And then the bastion host could be shut down. While they were in that environment, they were often interacting with a security management layer, right, that was typically done within a subnet per VPC, right? With the addition of VPC peering, though, we have the ability to think a little bit more broadly about how we might want to deploy that security management layer. So you could do it in subnets, you could do it on premise, or you could do it by creating VPC services layers in your broader workload deployment environment. And so the idea here is that you can have essentially private VPCs, public-facing VPCs, with VPC peering, tying them to a management and control layer, a command and control layer that might be supporting your AD or your DNS environment, although actually now we've got private DNS for Route 53, and we've got the AWS directory service. So those are also great options you can leverage as well. But you can also put your SIEM and your management and monitoring environment in that security control plane, right, or that security layer, and then use that to federate access and control out to the other VPCs. It gives you a shared environment that can be managed and monitored in a distributed fashion by your security team. And it allows you to also provide isolation and segmentation through security groups, ACLs, cross-account roles as well, to be able to work across a large array of accounts. And so you're allowed to, just as we were talking about earlier in the security architecture with an S at the end, right? It's this idea that you can build up this composable security layer and tie it all back to one or more control planes that are co-resident with your environment and are themselves protected and segmented off from the deployed environment. So it's still a separate command and control environment, protected off, lower attack surface, right?
Hi, thanks. So we've been encouraging this a lot, and it's all about reducing the time that someone has privilege. And in traditional environments, it's, especially if it takes, a week to get a change request approved or an identity access request approved, people tend to have persistent access because it's very hard to get it back if you take it away. Those are approvals and things like that. And that's important. Approval and acknowledgement and all that's important. But if you approve an architecture for the ability to assert access temporarily, that's what if you say, I don't need to approve your persistent access, I'm approving your ability to assert access. And the architecture is such that a user doesn't have they have a set of credentials like IAM credentials or maybe membership in an Active Directory group, but those correspond to roles, or they have the ability to and trust to assume a certain role. I talked about that a little bit before with the lifecycle identity management stuff. But this is important because they have credentials, but the credentials themselves are powerless, other than the ability to assume that role. And so there's several different assume role APIs built into Security Token Service. You can do it with SAML, you can do it with Web Identity Federation. There's a variety of ways to do this. But key thing being is that get in the habit, and actually especially with developers when they're writing code, is to not have access for the credentials that are being used to run the code against their APIs. Always assume roles when you can, because that access is just in time. It means that they have the ability to get that access, but it's done in a way that is only when the code is running. You can develop a couple of different behaviors around this, right? So certainly we talk about change management and tickets and things like that. So if there's an issue and someone needs access, they have that ability, but you can actually have the ticketing system or your change management system do that. So think how powerful it is to say, I have a maintenance window once a day or once a quarter or however often you push code, 10 times a day. But during that, there's no need to have access to the environment. There's absolutely not. So have the deployment system or the change system. If you have a scheduled maintenance window, once it goes to approved for that change, have an API call go and kick off a script that then opens up access just enough for you to make the change and then shuts it down again. So the just-in-time access is pretty important. One of the biggest behaviors and patterns we're seeing in customers who are highly effective security organizations and are moving to the cloud very fast, getting a lot of benefit, getting more secure more quickly, is that they've embraced this notion of DevSecOps. It's talked about in the Netflix talk. We talked about it in a few other ones as well. It's really a variety of things. So it's embedding security responsibilities, and again, this goes back to the RACI, the accountability and the responsibility into the development teams. And we've seen that over and over again. They know how to engineer security solutions. And security shouldn't be something that's just externalized, right? You don't do that for performance testing. You don't do it for unit testing. You don't do it for business functionality testing. Security testing and security has to be part of that development process. And because so many of the security controls and features at AWS are available through the APIs, it makes sense that the development teams or engineering teams combine into a cross-functional matrix team, at least at first, to get better security requirements into the dev pipeline. It ends up being a much more collaborative experience for both teams, especially in big enterprises that might have, a CISO organization that's maybe policy focused, maybe with some engineering around kind of network security controls and agents and things. Then we see them moving to dedicated teams, right? I mean, if it's matrix team and enterprise, eventually there's dedicated teams that have security engineering capability built into the dev teams. They're shipping business functioning code, features for the business to make revenue or to cut costs or things like that, but they're to launch new products, but they're embedding security folks in those teams. It's a very common behavior that we see. The shared infrastructure teams that you have today, right? I mean, they focus on a lot of things in these kind of highly performing security organizations. The teams that manage storage and network and things like that, they're collaborating too, but they focus more on things like consistency and tenancy and making those kind of decisions. But it's important to have them embedded as well. So some examples. You go from DevOps where it's these teams working together to ship functionality and have a fast feature flow in a very automated way. Inserting security into that as well, right? So one thing we've seen is that there's the idea of software deployed security, right? So rather than someone logging on to a host and installing like an agent or hardening the host manually or even running scripts, that's all part of the build pipeline, right? So when you ship code, you check in code, you make a commit, goes to a build pipeline, and then deploy pipeline. The security stuff is baked into that, and there's lots of great examples of that where the hardening happens, the agents get installed in Bootstrap, the things that do threat management or log management, they all get bootstrapped in there through orchestration. And I think it's an idea of beautiful IT. I mean, when it happens, and it happens really quickly, and it's a lights out environment. So in another talk, we did on healthcare yesterday, one of our customers has done thousands of code deploys, and they're building the entire environment with CloudFormation, but it's being run out of Jenkins, which is very cool because all of the CloudFormation templates, nobody has access to production, and they're launching all the security configuration out of Jenkins as a build pipeline. So you have total auditability and visibility to when things change, and you have artifacts that are coming out of the build process. Do you want to add to that?
Yeah.
Add anything to that?
Yeah, so one of the things that we think about, going back to that strategy early on when I mentioned infrastructure as code, is that when you're thinking about that software build pipeline, when you're treating infrastructure as code, it means you also have to be thinking about the security of the infrastructure code itself. So what kind of security unit tests are you doing on your CloudFormation templates as they move through the pipeline is a great example, right? It's this idea that when you have infrastructure as code and you've got software-defined security, everything is now ripe for inspection, evaluation, and promoting, or roll back, roll forward, right? Not just the business logic that's being pushed out into the environment, right? And so something that high-performing teams are doing is going as low in the stack as they possibly can, supported by that infrastructure as code cultural shift in the security organization.
Yeah. think with the launch of Lambda too, I think it opens up some really interesting possibilities. There's a lot of glue code that's been written to tie infrastructure changes and asset management systems and change management systems together to solve security problems. Lambda as a service, I think, is going to offer a lot of that. So an example that we heard already was whenever there's any sort of change or a code push, send some sort of an event to Lambda. And then the output of that is to glue together a vulnerability scan. And it's a great idea because most people do these big, large vulnerability scans in the entire environment. They take hours and hours to finish. And then by the time you're done, the data's stale or the job doesn't finish sometimes. With integrated with security in the code pipeline, when you know that you ship a piece of code, you know if that's a sensitive object or a sensitive library or something like that, you can trigger a Lambda event to then run additional code to go kick off your vulnerability scanners or something like that. So it's just in time, and it's focused only on what changed, not necessarily just this broad sweeping set of changes. So.
Yeah, perfect. So the last pattern we're going to talk about is that when you are starting to get hip to the DevSecOps culture and you're starting to become effective at that, it's this idea that the security organization can now focus on building security services and API that allows the rest of the enterprise to scale quickly. Right? And so often we're seeing enterprises first start thinking about what a secret service looks like, or a service that will help vend secrets to developers on demand, whether they're IAM roles, whether they're SSH keys, right? Or a variety of other credentials. One example of that is an IAM role catalog service, where you might start with the ability to develop, review, test, approve, and commit IAM roles that get pushed into a baseline catalog. You can then have a service pull from that baseline catalog, use administrative credentials to get a short-lived STS token that allows you to assume a security role that's trusted by all of the accounts that you want to push that baseline role into via cross-account roles, and then do a push of a common baseline of IAM roles across all of your individual accounts, which could be hundreds of thousands. So it's a way the security organization can rationalize and self-heal when it comes to short-lived ability to gain access to various bits of infrastructure in the AWS environment, where the service allows the independent development teams to continue to do the DevOps and DevSecOps thing, and then just call this when needed, right, to achieve a certain function. So with that, we really appreciate you guys taking the time to be with us today. These aren't by any means all of the patterns we see adopted by highly successful security-oriented companies, but there's certainly 10 of them. And we look forward to taking some questions off camera. Thank you.
Thanks a lot. Appreciate it.